AP review, my bad. And we're doing 2005 Form B, AB for response 1, which is a calculator problem. So you're given two functions, f and g, and you're given a graph where f is the top shape, they mark it as the top, and g is the bottom shape. So the first thing I do, because the calculator section, is I would put f in as your y1 and g in as your y2. That calculator syntax won't help you on the AP, but it's worth noting on your AP which one you made which. Cool. So part A asks me to find the area of R, right? So in order to find the area of R, I need to find the 2 points of intersection. It's pretty clear that this point of intersection is 0, and you can check that very quickly by plugging in 1 plus sine of 0 is 1, and e to the 0 is 1. So your first bound is definitely x equals 0. But to find the second bound that I'm going to call A, I'm going to need to find the point of intersection of these two curves. So the way I do that, right, is I picked a window that would work. I kind of guessed around until I found a good window. I want to do second calc, and I want to pick intersect, right? And I'm going to scroll up to where these guys intersect, close enough, right? Enter, enter, enter. And I'm going to get an x value that's like a 1.135, etc. Now I'm going to quit out of this, right? I'm going to hit second mode and quit out. And when I do that and hit x, it's going to give me, it's going to give me that value right there, right? And so I'm going to store that as alpha a. And I'm going to note that on my paper. So I'm going to write just once, right? I'm going to write that these guys intersect. So these guys intersect at x is approximately 1.135692535, which I'm going to call A, right? So in order to find the area between these curves, I want to integrate from 0 to A, and I can call it A because I labeled it once, right? Or you can list the whole thing, of the top curve, which they called f of x. I can always use their notation, minus the bottom curve, which they called g of x. I don't have to write out the functions because they named the functions f and g. Had they called both functions y, I would have had a problem. Now, what that means is that what I'm typing in my calculator is math 9, which is function integrate, y1 minus y2, with respect to x, from 0 to the thing I stored as a, right? But the AP doesn't want to see that. The AP wants to see this setup. They need to see that you found the bound and gave us all the places to the bound, and then they just want you to type. And when you do that, you're going to get an answer that is, if you go to 3 places, is a 0.429, and that's what they care about. So that's part A. Part B, find the volume of the solid generated when R is revolved about the x-axis. So now what they're talking about is they're talking about taking this shape and revolving this way, and that's going to create one of those annulus shapes. Now, I hate that they used R for the area because in these problems, it's way easier if you can think of big R and little r as the radii of the annulus. So the radius of the big circle of the annulus, right, the big radius, so R, I'm just going to use big R even though they already use big R for my own purposes. The big radius is from the top of this to the bottom, which in this case would be f of x minus the axis of rotation, which is conveniently just the x-axis. So my big radius is f of x. My little radius is the radius of the whole, which would be this curve minus the axis of rotation. So my little radius is g of x minus the axis of rotation, so just g of x. What that means is that the area of this annulus is pi big R squared minus pi little r squared. Again, this is not the big R as in the R they used for area. So if you want to factor out a pi, you can. If you want to do this, just the big mistake people make when they factor out a pi is they forget that each individual r is squared. It's not the quantity squared. So what that means, all of this is stuff that I can do in my own brain, right? Like, you don't necessarily have to communicate this with the AP, right? What they care about is that you're going to get that the volume is pi times the integral from the same bounds, 0 to a, of big R squared, so f of x squared, minus little r squared, so g of x quantity squared, with respect to x. This is what they need to see. You can call them f and g because they called them f and g. So they need to see that, and then they need to see an answer, right? That's what they need. Now, how you're going to get that answer, you're going to type it into your calculator as pi function integrate, in parentheses, y1 squared minus y2 squared, comma, with respect to x from 0 to the thing you stored as a. And when you do that, you're going to get 4.266 or 267, depending if you round or truncate. Again, the AP will not give you credit for this information, but you have to know how to put this stuff in your calculator. All right, cool. Part C. The region R is the base of a solid. For this solid, cross-sections perpendicular to the x-axis are semicircles with diameters extending from F to G. Find the volume of the solid. Cool. So what they're saying, and I'll see if I can give you a different color to draw this. So what they're saying is there's little semicircles sticking off this. So the diameter of a semicircle is F minus G, right? Top minus bottom, which means the radius of that semicircle is F minus G all over 2. Well, the area of a semicircle is 1/2 pi r squared. So the area of one of your semicircles is 1/2 pi times this whole quantity squared. And that's fine if you want to write it that way. You're the one typing it in a calculator, so how you feel comfortable typing it is entirely up to you. I would probably square these guys as a quantity and make this a 4. So I would probably make this a pi over 8 times this quantity squared. Notice this is the quantity squared, not the individual function squared. So if that's the area of one disk, in order to find the volume of this thing, you're again integrating from 0, which is the first semicircle, to A, which is the last one. So your volume is going to be pi over 8, the integral from 0 to A, of f of x minus g of x, entire quantity squared with respect to x. This is the volume formula that you need. You don't have to write what f and g are because they labeled them f and g, right? So you're going to do that, and you're going to give them an approximate symbol, and you're going to give them an answer, right? That's what the AP needs to see. But what you need to know how to enter is pi over 8. I like putting it in parentheses. You don't actually have to. Function integrate, which is math 9. And then in parentheses, y1 minus y2 quantity squared. That's its own set of parentheses with respect to x from 0 to a, right? And when you do that, you're going to get 0.077 or 0.078, depending on if you round or truncate. Cool beans?